Limiting reactant and percent yield. These are the last two topics in stoichiometry. Let's look at a real-world example here. You wake up early one Saturday morning and decide to make French toast for your whole family. You have a loaf of whole grain bread, 20 slices, a dozen organic farm fresh eggs, and a carton of rice milk, 8 cups. It takes 1 slice of bread for every piece of French toast, 1 egg makes 2 pieces of French toast, and a cup of soy milk makes 4 pieces of French toast. How many pieces of French toast can you make? What do you have left over? So if we think about this, we have 3 ingredients. We can call them reactants. And we're going to try to make as much product, as many pieces of French toast as possible. So let's look at this, kind of through what we've been doing. So first what we're going to do is we're going to think, all right, if all my pieces of bread are turned into French toast, how many pieces of French toast can I make? And so I set up a little conversion factor, my conversion factor, 1 piece of French toast for every 1 piece of bread. So if I start with 20 pieces of bread, my breads cancel out, I can make 20 pieces of French toast. All right, my dozen eggs. If I have 12 eggs, I said that I could make 2 pieces of French toast for every 1 egg. My eggs cancel out, and I'm left with 24 pieces of French toast. Last, my 8 cups of rice milk. I can make 4 pieces of French toast for every 1 cup. My cups cancel out. I could theoretically make 32 pieces of French toast. All right, which one here is going to limit how many pieces of French toast we can make? So let's think here. What is the theoretical yield of French toast? Theoretically, if all our ingredients were turned into French toast, what's the most pieces of French toast we can make? Hopefully we're all saying 20. Because that's where the bread, that's what we would run out of bread after 20 pieces of French toast. Which reactant will we run out of first? Bread. Since the bread runs out after 20 slices, it limits the amount of French toast we can make. So that would be considered our limiting reactant. Would be the bread. I'll say LR for limiting reactant is our bread. Our theoretical yield is 20 pieces of French toast. All right, now, how many eggs and how much rice milk do we have left over? To do this, we need to work backwards. We need to say we made 20 pieces of French toast. How many eggs actually went into making that? We made 20 pieces of French toast. How many cups of rice milk actually went into making that? So we look down here. My first one. I start now with 20 pieces of French toast. I completely ignore how many eggs I started with for now. All I care about is how many eggs went into making that French toast, those 20 pieces of French toast. So I use my conversion factor. I just flip it around so that I get eggs. 20 pieces of French toast times 1 egg for every 2 pieces of French toast. I used 10 eggs. 20 pieces of French toast times 1 cup for every 4 pieces of French toast. I used 5 cups of rice milk. So if we started with a dozen eggs and we use 10, 12 to start, we use 10, we have 2 left over. Does that make sense? Is that pretty easy? Hopefully not too bad. Now if I had 8 cups of rice milk, that's what I started with. Start. I used up 5. Now I have 3 left over. And that's as hard as limiting reactant problems get. Is you start with a certain amount, you figure out your theoretical yield, your limiting reactant, and then they might ask you how much is left over. It's really, really important that you work backwards when they ask you how much is left over. Because what a lot of people will do is take like 20 French toast and subtract 12 eggs. It doesn't make any sense when you do it that way. You have to work backwards. You have to figure out, I'm going to start with my theoretical yield here of 20 pieces of French toast. How many eggs went into making that? And then subtract it from how many eggs you started with. All right, let's look at a chemical or a chemistry example of this. A 2-gram sample of ammonia is mixed with 4 grams of oxygen to produce nitrogen monoxide and water. What is the theoretical yield of nitrogen monoxide? All right, write a balanced equation. Ammonia, which we find in Windex, is NH3 plus oxygen. We know oxygen is O2 to produce nitrogen monoxide. So the balance formula for that must be just NO, 1 nitrogen and 1 oxygen, plus water. I got that one for you. No, maybe I don't. H2O. Now I have to balance it. All right, well, I see I have 3 hydrogens on one side, only 2 on the other, so I got to make those 6. Also, I'll put a 2 in front of my NH3, 3 in front of my H2O. That changes how many nitrogens I have. Now I have 2 nitrogens, so I have to put a 2 there. Let's see how my oxygens are. I have 2 in NO and 3 in O2, in H2O, sorry, for a total of 5 oxygens on the right-hand side. But my oxygens only come in pairs. So what's the little trick that I can do to get those, basically get the ones on the right-hand side to an even number? I multiply everything times 2. That turns into a 4. That turns into a 4. That turns into a 6. And now instead of 5, I have 10. So I could just put over here, to get 10, I could put a 5 in front of my O2s. So 4 NH3 plus 5 O2 yields 4 NO2, or I'm sorry, 4 NO plus 6 H2O. There's my balanced formula.